student, myself Pavitra. Thank you all for being part of Pavitra Chemistry. Let us review the key points of previous class. In previous class, we discussed about the composition of matter. Matter composed by two small particle. One is the atom, another is the molecule. Atom is the smallest particle of an element. Molecule is the smallest particle of compound. Next definition of molecules. Two types of molecules are found. One homoatomic molecule. Next is your heteroatomic molecule. These are the examples of homoatomic molecules. Homoatomic molecule can be classified into different types. That is your monoatomic molecule, diatomic molecule, triatomic molecule, tetraatomic molecule, octatomic molecule, like this. Next, heteroatomic molecule also classified into different types. These are diatomic, triatomic, tetraatomic, pentatomic, like this. The molecule is classified depending upon the type of atom. Whether same type, then it is your homo. Different types, then it is your hetero. Next, I discussed about the property of matter. Normally, we classified the property of matter into two types. One is your physical property. Next is the chemical property. Next, basing upon the quantity of matter, depending upon the quantity of matter, property can be classified into two types. One is your extensive property, another is your intensive property. Volume is an extensive property, melting point, boiling point are the intensive property. Next, I discussed about some special property, that is your hygroscopicity, efflorescence, deliquescency. Hygroscopicity means it combine moisture of the atmosphere and convert it into that is your hydroxide or hydrate. Efflorescence means loss of water and the crystalline hydrate molecules loses water molecule and converted into powder form. Next is the deliquescency. It combined with the moisture of the atmosphere until it is dissolved. Next, I discussed about the malleability. Malleability means to be hammered into sheet. Ductility means drawn into wire. Next, I discussed about the plasticity. Plasticity means it cannot regain its original shape, size, or volume. Elasticity means it regain its original shape, size, or volume. And today I will explain about what is symbol, different way of writing symbol with examples. Next, I will explain about what is the valency. Next, I will move to the radicals and types of radical. At first, I will explain about what is symbol. Before going to the definition of symbol, I will show an example of an element. Suppose think about the hydrogen element. I can write the hydrogen element name like this: HYDROGN. This is the name of hydrogen element. Similarly, you can think about name of boron, name of carbon, nitrogen, fluorine, like this. You can think about helium, calcium, silicon. These are the name of different elements. But when we will use these elements in chemical reaction, then it is very difficult to write the full name of the element. And also in many other cases, it is difficult to write full name of an element. So here we can think about the shorthand representation of the element, or you can think about the abbreviation of the elements. For this purpose, we think about the symbol. Symbol is nothing but it is the shorthand representation or abbreviation of the full name of an element. For example, if you think about hydrogen, Hydrogen is written like this, HYDROGN. This is the name of hydrogen. But if you think about the symbol of hydrogen, then it can be written as simply H. Similarly, think about boron B, carbon C, nitrogen N, helium He, chlorine Cl. These are the symbols of the corresponding elements. So, symbol is nothing but it is the shortened representation or abbreviation of the full name of an element. There are certain way of writing the symbol of an elements. At first, I will discuss about the first point. Some elements are represented by the first letter of the name, which is always capitalized. That means the letter must be capital. Take examples. Here, the element is your hydrogen. The first letter is your H. So, the symbol of hydrogen is your H, and the H must be written in capital form. Similarly, other example are boron. Your first letter is B. The symbol is B. Similarly, here the name of carbon element is given, that is your CrBN. First letter is C, so the symbol is C. Like that, you can think about nitrogen element, fluorine element, all the written in their short form. That is your shortened representation, and these elements are written in the way of first letter. That means see, the symbol is made by using the first letter of the name of the elements. In some cases, what will happen, two letters are used, and the two letters are the first two letter. Among the two letter, the first letter must be capital. For example, if you think about your helium, the spelling is your HELIUM, but here the first letter is H and the second letter is the E. The symbol is here given is your HE. That means here the for writing the symbol of helium, we use the first two letter, and the first letter must be capital. That is your the first letter is your H. So here I have written H as a in capital form. Similarly, you think about calcium. Spelling is your ClCium. Here the symbol is your Ca. Similarly, you think about silicon, Si, nickel, Ni, titanium, Ti. Think other examples. In some cases, also two letters are used for writing the symbol, but the two letter must not be the first two letters. The second letter may be any letter. Here, look at that chlorine. The spelling is your CHLORINE. The first two letter is your CH, but here the symbol is not written as CH. Here the symbol is your Cl. That means for writing this symbol, here first letter C is used, and the third letter, that is your L, is used. That means the second letter may be any letter of the name of the elements. Similarly, you can think about the chromium. Here the symbol is your Cr. Like that, you can think about the zinc. Here the symbol is Zn. Next is the bromine. Here the symbol is Br. Strontium, that is your that is the you can think about Sr. But in case of some cases, we generally depends upon the name, Latin name or Germany name of the Germany names. The symbols of the symbols of such elements are given in the table here. Look at that. Here we think about the sodium. Here we cannot use the symbol as S or SO or SD like that. Here the symbol of sodium is your Na, and Na is completely related to the Latin name of sodium, that is your natrium. The Latin name of sodium is your latrium. That means here we think about Na. The first two letter is your Na. So here we think about the symbol Na. Next, move to the potassium. Latin name is your Kalium. So we think about K. Like that, you think about iron, ferrum, Fe, copper, Q from Cu. Here L for Latin name, G for Germany name. Think about silver, argentinum, Ag, tin, stannum, Sn, antimony, stibbium, Sb, tungsten, wolfram, W. This is the German name. Gold, aurum, Au, mercury, hydragarium, Hg, lead, plumbum, Pb. These are the list of elements whose symbol is derived from the Latin name or German name of the elements. Next, some elements also have the symbol which is derived from the name of the scientist or name of the country or name of the laboratory or name of the planet. Look at that. Here I have given some examples of elements whose symbols are derived from the name of scientist. For example, if you think about curium, curium is named by the name of scientist Madame Curie. Your cm related to the name of the scientist Madame Curie. Next, you think about Einsteinium. Albert Einstein symbol is your ES. Fermium, Enrico Fermi, AFM. Novelium, Alfred Nobel, NO. Mendeleev, MD. These are the list of elements whose symbols are derived from the name of scientist. Next, you can move the example of some elements whose symbol is derived from the name of country or laboratory. Here, I used the symbol L for laboratory and C for country. For example, think about Bracklinium. It is named according to the name of the laboratory, that is University of Berkeley. Here look at that. BK is given as a symbol for Berkelium. Similarly, think about Californium, University of California. It is the name of laboratory. That is your CF. Think about Polonium, Poland. It is the name of a country, and the symbol is your PO. Like that, you think about American. The name is your America. The name is depend upon the country name America. Here we can think about AM, Germanium. Depends country German, and its symbol is GE. Similarly, Russia, that is your ruthenium, Ru. These are the list of elements whose symbol is derived from the name of the country or laboratory. Like that, you can think about some elements whose symbol is derived from the name of planet. Here, uranium comes from the name of the planet Uranus, whose symbol is U. Next, you can think about Neptunium. It deals with the name of planet Neptune. Symbol is your NP. Next, you can think about plutonium. It is related to the planet Pluto, and its symbol is Pu. Look at that. This is all about the symbol and how can you write symbol of an elements. No, it is highly necessary to remember all the symbols of the elements. Otherwise, you will face many problems in future study, because generally in books or in exams the question will written in the form of symbol. That's why it is necessary to remember all the symbols of each elements. Next, I will move to the valency. What is the valency? You know very well about the valence means Jojyata. Remember, symbol means you can think about Sanketa, but valence means here you can think about Jojyata. Sorry, symbol means you can think about Pratika, not Sanketa. Next, we move to the valency. Valency means here we can think about Jojyata. What is valency? I will explain. Look at that. Here you can remember stable electronic configuration. What is the meaning of stable electronic configuration? Stable electronic configuration is nothing but it clearly depends upon the electronic configuration. I will explain the electronic configuration in the um, atomic structure unit. Uh, here I will explain of atomic structure, and how can you know that which element having stable electronic configuration and which element do not have stable electronic configuration, and which do not have unstable which have stable electronic configuration or not. In At first, I want to show something. Look at that. Here, helium is given. Helium having two electron. Out of the two electron, all the electrons are present in the K cell. Here, if you will think about the valency cell, then valency cell having two electron in the outermost cell. Similarly, think about nitrogen. Here, nitrogen having 8 electron in the valency cell. Yeah, nitrogen having atomic, here neon. I want to speak about neon. Here, neon having 8 electron in the valency cell. Its electronic configuration is 2 8. That means 8 electron present in the valency cell. Similarly, you think about argon. Argon having atomic number is 18. It have also 8 electron in the valency cell. These elements obey octet rule and doublet rule. Here, neon obey octet rule, argon obey also octet rule. But if you think about helium, helium obey dualet rule. So these elements are said to be stable because it has stable electronic configuration. These elements obey the stable electronic configuration rule. That's why they are said to be more stable. Uh, every elements wants to make stable electronic configuration um, by following the octet and dualet rule. Next, I will think about another example. Suppose think about sodium. Sodium here having stable electronic configuration. Sodium always wants to stay stable. Similarly, think about chlorine. Chlorine have also a tendency to make stable electronic configuration. If you will think about the sodium, sodium having the electronic configuration like this, that is your 281. Look at that. Here the valency cell is your M cell, and it having one electron. This is the one electron. So it is an unstable element. Similarly, if you think about the chlorine, chlorine having atomic number, that is your 17. So chlorine also wants to stable. If you think about the electronic configuration, the electronic configuration is your 2, 8, 7. This is the electronic configuration of chlorine. Here, chlorine also do not have stable electronic configuration. For that purpose, chlorine always wants one electron to make stability. That means here I can say that every elements have a tendency to acquire the nearest noble gas configuration, that is your stable electronic configuration. For this purpose, every element have a different way to achieve the stable electronic configuration. First way is they can gain the electron from the nearest atoms, or they can loses their electron to the nearest atom, or they can share the electron with the nearest atom. If you will think about sodium always wants to um, remove these electrons, and it maintain and acquire the electronic configuration of neon. Neon having 10 electrons, and its electronic configuration is 28. That means sodium always wants to change its electronic configuration from 281 to 28. Similarly, if you will think about chlorine, chlorine also have a tendency to attain the stable electronic configuration. Here we can think about that chlorine having electronic configuration like this, 287. It always converted to 288. It can be only possible when chlorine accept an electron from other atom, and uh, place the extra electron in the valency cell, then it can source 288 electronic configuration. That means it is stable. Suppose here look at that. Here sodium having an extra electron, but chlorine having an one electron deficiency of one electron. So if you will combine sodium and chlorine, then what happens? NaCl will form, and in that case, what happen? Sodium loses one electron to chlorine. As a result, what happens? The electronic configuration of sodium is now 28, and the lost electron of sodium is gained by the chlorine, and it converted its electronic configuration to 287 to 288. Now, both sodium and chlorine will stable. um, for attaining such type of stability, sodium loses one electron, chlorine gain one electron. So in this case, we can say that the valence of sodium is your one, and the valence of chlorine is your also one. Similarly, if you think about another example, chlorine molecules. This is the diagrammatical representation. Suppose think about chlorine molecules. Here, chlorine needs one electron. This chlorine also needs one electron. It have electronic configuration like your 287. Here, the electronic configuration also 287. It needs one electron. It also needs one electron. For this purpose, they share one electrons with each other like this. So when you will think about the stability of these both chlorines, you can think about like this. That means if you will count the number of electron present in the valency cell, you can count like this: one, two, three, four. This is your five, six, and this is your seven electron. Actually, this is the electron of this chlorine atom, but since they are sharing with each other for maintaining the stability, it needs this electron helps to the atom. That means it counted in the octet rule. That means you can think about 8 electrons. This is the 8 electron for this atom. Now think that there are 8 electron in the valency cell. By adding this electron, and this electron is the electron of this atom. Similarly, if you think about the stability of this atom, Now count the electron: 1, 2, 3, 4. This is a 5. This is your 6, and this is your 7. But this electron is the electron of this atom. Since they are sharing with each other, so this electron is also count for this atom. Like this way, they can maintain their stability and attain the nearest noble gas configuration, that is a stable electronic configuration. Um, that is a 288. This is the electronic configuration of argon. We can conclude an important point that what is valency and what are the examples of valency. Look at that. What is the sentence here given? Lost or gained or shared of an electron. The number of electron lost or gained or shared by an atom of an element to acquire the stable electronic configuration of nearest inert gas element is called valency. Valence is nothing but it is the number of electrons lost or gained or shared by an atom of an element to acquire stable electronic configuration. For example, valency of sodium means 1 because it lost one electron. Similarly, valency of chlorine is also 1 because it gained one electron. It can possible in case of NaCl. Similarly, if you think about chlorine molecule, in case of chlorine molecules, both chlorine atoms add one electron, so the valence is also 1. Valency of an element is always a whole number or 0. Maybe they loses the whole number of electron, or they do not want to lose any electron. They cannot they cannot lost or gain half of electron, 1/3 portion of electron, like that. So we can think that valency of an element is always a whole number or 0. Similarly, if an element do not want to lose, gain, or share electron, because it himself obey the octet rule, that means it have 8 electron in the valencer or 2 electron in the valency cell. So, such type of elements having the zero valency. Example is your helium. Helium having already 2 electron in their valency cell, so it does not needs any electron to share or loss or gain. Similarly, you can think about the uh, mm, that is your neon. Neon already stable electronic configuration, so it is not necessary to gain or lose any electron from other. So here neon having also valency of 0, like that argon having also valency of 0. Next, you can think about other point. Valency is the combining capacity of an element or radical. For example, how can I will explain chlorine. Chlorine having valency 1. That means it can form one single bond. If you think about the covalent bond, that means it explains the combining capacity of an atom of an element. There are some elements whose valency will change, fixed, and some elements whose valency will change. If you think about the element like lithium, sodium, potassium, barium, magnesium, calcium, strontium, and aluminum, these elements having fixed valency. Lithium, sodium, potassium having one valency, but beryllium, magnesium, calcium, strontium, barium having two valency, aluminum having three valency. The valency of these elements do not changes. If you think about iron, copper, lead, Sn, Au, there are more than one valency, so they having variable valency. Iron having two valency, that is O2 and 3, I will explain such type of things in the structure of atom units. Here we can explain clearly how iron shows two valency, one is your two, another is your three. Similarly, copper, lead, tin having also more than one valency. Here I have given a list of elements and their variable valency. It is highly necessary to remember the valency of uh, atom. Otherwise, you cannot write the formula of an compound. So, it is highly necessary to remember the valency of each elements. Next, I will move to the radical. What is a radical? Generally, two types of radical we can present: electropositive radical, electronegative radical. At first, I want to say that what is a radical. Suppose I want to say that, look at that, here H plus is written. Suppose I want to say that what is the charge of your hydrogen. You can say that that is your plus. And what is the magnitude? 1, that is your, you can say that plus 1. Plus 1 is the total charge of the hydrogen. Here what will happen? Lithium Li plus. Here also the charge of lithium is your plus. But if you think about here, you can say that it is a group of atom. This species is made by a group of atom, that is your one is your nitrogen, another is your hydrogen. There are four hydrogen is also present. Can you say that the plus charge belongs to nitrogen or four hydrogen or total NH4 plus? You can say that the plus charge is the total. That means here I can use an parenthesis bracket. You can write here a parenthesis bracket. Actually, it is highly necessary to write a parenthesis bracket, but since it can understandable, so you don't write, no, it is not necessary to give a parenthesis bracket. All are known that the plus charge is the total charge of the species. That means the plus charge depends upon the charge of nitrogen and 4 hydrogen. It is not for only the hydrogen. Similarly, if you think about Fe2 plus, here how what is the charge? 2 plus. Cu2 plus also having 2 plus charge. Like that, you can think about here. Another some radicals are given. That is your SO42 minus, PO43 minus, F minus, Br minus. Then what is the definition of radical? Radical is nothing but it is a species that having an atom or group of atom. Here look at that. If you think about H plus, here a single atom is present. If you think about NH4 plus, here number of two type of atom is present. If you think about total number of atom, that is your 5 number of atom is present. That means these are said to be radicals. So here I can say that an atom or group of atom that behaves as a single unit. Totally it is considered NH4 plus means plus responsible totally is a single unit, that is your NH4 as a single unit and carry either positive or negative charge. It's called radical. Again, I will repeat: radical is a species which is made by an atom or group of atom, but it behaves a single unit and carry either a positive charge or negative charge. Due to that means depending upon the charge of the radicals, radical can be classified into two types. That is your electropositive radical, or here you can say that basic radical or cation. Similarly, if you think about other is your electronegative radical or acid radical or anion. There are two types of radical. One is your basic radical, another is your electro negative radical or acid radical or anion. Next, I will move to the electropositive radical. Electropositive radical must have the positive charge. Here you can say that these are the example of electropositive radical. Look at that, all radical having positive charge, so these are said to be positive radical. Uh, Here I can explain the positive charged radicals are referred to as a basic radicals. Here the examples are given. If you think about the negative radicals, the negatively charged radical are referred to as a acid radical. Here list of radical is given, that is your Cl minus, F minus, Br minus, SO4 2 minus, PO4 3 minus. These are the list of radicals belongs to electronegative radicals. This is the first classification of radical depending upon the charge. Next, I will move to the other classification depending upon the structure of radicals. Depending upon the structure, radicals are classified into three types. One is the simple radical, next is the compound radical, next is the complex radical. Look at that. I will explain clearly. Here the simple radicals are given. That is your Na plus, O22 minus, O222 minus. Next is the compound radical, NO3 minus, SO4 2 minus, PO4 3 minus, NH4 plus minus, NH4 plus. Complex radical is your FeCN6 3 minus, here AgNH3 twice plus CuNH3 plus CuNH3 4 plus. These are the complex radical and these are the compound radical. This is the simple radical. If we'll compare, look at that. If you think about sodium, it is Na plus radical. It is made by only one kind of atom and one number of atom. It is made by atoms of the same element. That is your sodium. Yeah, here you can think that O2 2 minus. Here it is made by two atom and the two atom are belongs to the oxygen element. That means they belong to the same element. Here I can say that the radical which contain one or more atom of the same element, that is called simple radical. Example here given, Na plus, O2 minus, O2 2 minus, etc. If we will think about the compound radical, look at that. At first I will see about the NO3 minus. Here two type of atom is present. One is a nitrogen, other is the oxygen. And the two atoms, no doubt there are total number of atoms is your 4. Among the 4 atom, two type of atom, among the 4 number of atoms, two type of atom is present. One is your nitrogen, another is your oxygen. They belongs to completely different elements. This is the difference between the simple radical, compound radical. Simple radical made by one or more atoms of the same element. Compound radical is made by two or more atoms of different element. Different means at least we need two. Same means you can form by one atom, but different means you can say that about at least two. So here I can write here the radical that contain two or more atoms of different element as a single entity, and single entity means the minus charge is completely the charge, total charge of the nitrogen and oxygen. Nitrogen oxygen combinedly represents the to this minus charge. These are said to be compound radical because it is made by two or more atoms of different element and the charge is represented as a single entity. Next, we move to the complex radical. Look at that. Here also, two or more atoms of different elements are present. But look at that. Here a square bracket is given. But here there is no square bracket is present. You can give the parenthesis bracket. But here we can. It is highly need to give square bracket. These compounds are completely belongs to the coordination compound. You will read the coordination compound in the plus two second year. Also, you read vastly in the higher study. Look at that. These radicals are made by two or more atoms of different elements, and they are given in a square bracket. They are little complicated. Such type of elements are said to be complex radical. And such type of radicals are considered the compound radical. Such type of radicals are said to be simple radical. This is the classification depending upon the structure of radical. Next, I will move the other classification depending upon the magnitude of the charge. Radical are classified into various types. Magnitude of charge means what? Suppose think about H plus. Here the charge is plus, but the magnitude of the charge is your 1. Similarly, if you think about Cl minus, here the charge is your negative minus, but the magnitude is your 1. Similarly, if you think about Ca2 plus, here the charge is positive, but the magnitude is your 2. Like that, if you think about PO43 minus, here the charge is your negative, but the magnitude of the charge is your 3. If both acid radical or basic radical having one unit of positive or negative charge, then such type of radical are said to be monovalent radicals. Similarly, you can think about divalent or bivalent radicals. Look at that. All the radicals having a magnitude of 2. That means both positive and negative radicals having charge magnitude of the charge is your 2. That means it is said to be divalent or bivalent radicals. Similarly, you can think about the trivalent radical. The radical that carry 3 units of positive or negative charge are called trivalent radical. Here I have given some example: N3 minus, P3 minus, PO43 minus, Ti3 plus. Or similarly, think about the tetravalent radical. The radical that carry 4 units of positive or negative charge are called tetravalent radical. SN4 plus, Pb4 plus, P2O7 4 minus, etc. Next, move to the pentavalent radical. The radical that carry 5 units of positive or negative charge are called pentavalent radical. S5 plus, Sb5 plus, etc. These are the three way of classification of radical. First classification is your what? Depending upon the charge, nature of the charge. One is your, I can say that electropositive radical or basic radical or cation. Next is the electronegative radical or acid radical or anion. Next, I will move to the other classification, second classification, that is your depending upon the structure of the radical. That is your one is your simple radical, compound radical, complex radical. Next, I will move to the third classification, that is your depending upon the magnitude of the charge, monovalent, divalent, trivalent, tetravalent, pentavalent. Yeah, here is the this is all about the classification of the radicals. Let move to some radicals which are listed in different way of table. List of positive radicals. First, I will discuss about the monovalent radicals. These are the examples of monovalent radical belongs to electropositive radicals. Here I have given the names. H plus means you can call hydrogen, Ag plus means silver, sodium means Na plus. But if you think about H3O plus, that is just said to be hydronium ion. It is highly necessary to remember all the names of the radicals. Without these, you can unable to write the formula of a compound. For writing the formula of a compound, it is highly necessary to remember the name of the radicals. Similarly, Oros means plus, Au plus, nitronium NO2 plus, ammonium NH4 plus, lithium Li plus, nitrosonium NO plus. So try to remember these the name of these radicals. Next, move to the divalent radicals. You can think about barium, Ba2 plus. Similarly, beryllium, cadmium, calcium. Here I have written chromos or chromium double I. Here the double I belongs to the oxidation number. Here the oxidation number of chromium is 2. Here so I have given double I. If oxidation number 1, then I will give the I. If 4, then I will give IV. Plumbus or lead, that is your Pb2 plus. Mercury or mercury double I Hg2 Hg2 plus. Similarly, think about stannous or tin Sn2 plus. These are the list of divalent radical. All are belongs to the electropositive radicals. Similarly, think about the trivalent radical, that is your aluminum Al3 plus, arsenios or arsenic As3 plus, bismuth Bi3 plus, ferric or iron Fe3 plus. These are the list of trivalent radical. It is necessary to remember the name of the radicals. Next, look at that. This is the list of tetravalent radicals. All are belongs to electropositive radicals. The names are also given in the table. Next, these are the list of pentavalent radicals. It is highly necessary to remember all the name of the radicals. This is the few list of electropositive radicals. Next, I will move to the list of electronegative radicals. At first, I will discuss about the monovalent radical. Look at that. These are the list of monovalent electronegative radical. That is your acid radical. Here you can remember the name. Your NO3 minus means your nitrate. NO2 minus, that is your said to be nitrate. Permanganate MnO4 minus. Next is your superoxide O2, O2 minus. Azide N3 minus. There are some monovalent acid radicals are given. Their names are also given. You should remember this. Next, divalent radical, carbonate CO3 2 minus, tannate SnO2 3 minus, chromate CrO4 2 minus, sulfate SO4 2 minus, sulfide SO3 2 minus, sulfide S2 minus. Remember these radical names. Next is the trivalent radical, aluminate, oxybromide, vanadite, ferricyanide, ferricyanide. This is your ferricyanide, not FeI. That is your said to be ferricyanide. Arsenite, borate. Next is your list of tetravalent radical. Remember these radicals. You can also think about the pentavalent radicals, but these radicals are highly unstable. Also remember some particular radicals. Otherwise, you unable to write the formula of a compound. Next class, I will discuss about the formula of a compound. So before coming to this class, so remember the name of the radicals. uh, I will teach you some tricks how to remember the radical name of the radicals. At first, I will want to write something. Remember some important points. Or you have seen some examples. In that examples, you can see about ferrous and another is your ferric. Here, what happens? One is your OS is used, another is your E is used. Suppose I will give two symbols, Fe2 plus, another is your Fe3 plus. Among these two, one is your ferrous, another is your ferric. How can you easily detect which belongs to ferrous and which belongs to ferric? Remember an important point, os always for lower oxidation state. I will explain about the oxidation state in future class. For now, you can simply remember oxidation number. Simple thing about a what, that is your oxidation number. Here, os is given to the lower oxidation number species, E is given to the higher oxidation species. Let me explain. Ferrous means you think about Fe2 plus. This is your lower. Charge is your 2 plus. Your oxidation number is your 2. You can think about also valency. If you think about your 3 plus means higher than 2 plus. That means it belongs to your ferric. Always remember os is lower, ec for higher. Similarly, you can think about another example, that is your, suppose I want to show you stannostanic. Similarly, you can think about plumblic. Similarly, cupros cupric. Suppose I want to see you Cu plus Cu2 plus. This is your cupros. This is your cupric. Ec for higher, os for lower. It is highly necessary to remember these things. This is one trick. Os always belongs to lower, ec belongs to always higher. Next, I will give another example, another trick, second trick. You can think about ID. Next is your IT. Next is your, you can think about 80. One is your ID, second is your IT, next is your 80. ID always remember, it is a simple ion. Simple ion without any oxygen. Without any oxygen. It is a simple ion. But if you think about IT, it belongs to element with the oxygen. Uh, Remember, I will give you an example, then you can clearly understood. And it is also element plus oxygen. But remember, here you can think about the lower number of oxygen. Here you can think about the higher number of oxygen. Or let me explain. S2 minus SO4. You can think about SO4, SO3 2 minus. Next is your SO4 2 minus. One is the, I can write here. One is a sulfide. Another is your sulfate. Next is your sulfite. Then tell me which belongs. What is the name of this? It is your sulfide or sulfite. Here I have written simple without any oxygen. Tell me, ID is your this. This is your ID sulfide. That means here see that which radical having no oxygen. This S2 minus. S2 minus do not have oxygen. That means I can combine here. Sulfide means S2 minus. Let me explain about AT and IT. IT related to element plus oxygen. Here the element is your sulfur and oxygen here given both. In these two cases, both oxygens are given and elements are given. But if you think about this, here the number of oxygen atom is your 3. Here the number of oxygen atom is your 4. Here I have written element plus oxygen plus lower number of oxygen. Element plus oxygen with higher number. That means here 3 oxygen present, here 4 oxygen. It is lower, then this is your higher. So here I can see that this is the name of sulfide. This is the name of sulfite. It is for lower. Next, I can write here. This is for sulfate. Again, I will repeat. Remember this ID simple ion without any oxygen. IT element plus oxygen with the lower oxygen. AT element with a higher oxygen. Take another example. Suppose I want to give one is the phosphide that belongs to ID. Another is your phosphate. Next is your, suppose I will give to you phosphite. Suppose I will give some symbol. That is your PO4 3 minus PO3 minus P3 minus. Then tell me which belongs to which radical. ID. ID means it does not need any oxygen. Look at that. Here there is no oxygen. That means phosphide is here. P3 minus. Next, both having oxygen and with their elements. But here oxygen 4, here oxygen, here you can say 3. That means element plus lower oxygen number. Lower oxygen means here belongs to IT. That means here I can say that PO3 3 minus is your phosphate. And this is your element with oxygen of higher. That means here you can say that PO4 3 minus is your phosphate. Take another example. You can easily remember. Think that N3 minus NO2, NO3 minus NO2 minus. One is your nitrate, second is nitrite, third is a nitride. ID. ID means no oxygen. That means this. AT, higher oxygen. Here 3, here 2 oxygen. You can write here this. Nitrite, NO2 minus. There are some few tricks. You can easily identify which radical is what is the name of the radicals. Next, I will give another important point. Suppose think about by hydrogen sulfate, or it is said to be bisulfate. Here I can write here what I want to say. S2 minus, that is just simply you can think about sulfide. SO4 2 minus, here you can say that this is your sulfate. Similarly think about SO4, sorry, SO3 2 minus. This is your said to be sulfite. This is your said to be what? Sulfite. Remember, suppose a formula is given here, HS minus. Look at that. If you think compare these two things, S minus, S2 minus. Here what happens, if you add H plus ion with this radical, then it converted to like this. Suppose I will add H plus ion to this radical, then what will happens? One, there are two negative charge, one positive charge here. Cancel, if you will cancel, then one negative charge will remain. That means here S2 minus. This is the name of hydrogen sulfide. S2 minus means hydrogen sulfide. Then what will be the name of this? This is your hydrogen sulfide. Here you can say that bisulfide, hydrogen sulfide. Similarly, if you think about this is your said to be sulfate. Suppose I want to write bisulfate. Then what will be the symbol? Add H plus here. You can write here HSO4, HSO4 minus. Reduce one minus because you have to add one H plus. That is your, you can also say to that hydrogen sulfate, bisulfate, or you can simply say that hydrogen sulfate. Similarly, think about this example. Suppose I want to add H plus, Then what will be the other radical? HSO3 minus. This is your said to be this is your said to be sulfide. This is your said to be hydrogen sulfide or bisulfide. Take another example. Suppose think about phosphate. Phosphate is your P4 3 minus. This is your said to be phosphate. Suppose I want to say about HPO4 2 minus. What happens? 1H plus added and there is a reduction of negative charge. Similarly, you can think about other H2PO3 minus. What happens? There is a decrease in the negative charge. Then what will be the name? This is your phosphate. This is your said to be biphosphate. This is your said to be biphosphate, or simply you can call hydrogen phosphate. Hydrogen phosphate. If you will think about this, what is the name of this? Here you can say that dihydrogen phosphate. Dihydrogen phosphate. There are two hydrogen. These are the few examples by which you can able to remember the name of the radicals. Next, take another trick. Remember an important thing. Before sometimes I have given some trick, that is your OSIC. If you think about OS means OS means related to lower oxidation state. EK is related to higher. If the oxidation number again increase, that means very much high. Very high. You can write here very high. Here you can also write very low. Ost very low means as compared to the os. Very high means as compared to the ek. If an compound having central atom and it having lower oxidation, very low oxidation state, then you can say, think about hypo. Suppose more higher oxidation, that is just said to be poor. Take example. Suppose I want to think about what is the name of this? Cl minus. Cl minus is your chloride. Here the oxidation number is your minus 1. I will explain about the oxidation number in the future class. So keep wait. Suppose I want to think about ClO minus. If you will find the oxidation number, then the oxidation number of chlorine is your what? Plus 1. Next, suppose I want to move ClO2 minus. Next, I will move to the other example, ClO3 minus. Next is your ClO4 minus. Look at that. If I'll find out the oxidation number of chlorine here, then the oxidation number is your plus 3. Here you can find plus 5, and here you can find plus 7. This is a chloride, no doubt. Keep away from this example. Here the lower, if you think about the general oxidation, this is your, suppose I will think low. This is your high. Then this is your very high, and this is your said to be very low. Look at that. Again, I want to say here. This is your plus 1. This is your having plus 3. This is your plus 5. This is your plus 7. This is very low. This is your low. This is your high. And this is your very high. For this purpose, we have used what? This is your os, this is your eek, and this is your por, and this is your said to be hypo. Suppose what will be the name of this compound? ClO2 minus. ClO2 minus is your what? I can write here. ClO2 minus. That is your. We can write here chloride. Chloride. Uh, Next is your, suppose I want to write here ClO3 minus. This is your chlorate. Next I will move to ClO4 minus. That is your very high oxidation state. That is your said to be perchlorate. That is your said to be perchlorate. Suppose I move to ClO minus, then this is your said to be hypochlorite. Hypochlorite. Again, I will give you some explanation. That is your hypo, os, ec, por. Os is the lower, ec is the higher. Much more higher. That is very high is your considered as a por. Very low considered as your hypo. This is the examples. ClO minus, ClO2 minus, ClO3 minus, ClO4 minus. Here the oxidation number is your plus 1. This is your plus 3. This is plus 5. This is plus 7. Here is the lower is the plus 3. This is very low, this is high, and this is very high. So accordingly I have written here Cl minus, that is your hypochlorite, ClO2 minus chloride, ClO3 minus is your chlorate, ClO4 minus is your perchlorate. These are the few tricks you can remember this. Accordingly you remember the name of the each radicals. It is highly necessary because without the name you cannot able to write the formula of a compound. Now okay, for this class, next class I will be discuss about formula, steps for writing formula of a compound, chemical equation, algebraic method to balance an equation. It is also a trick how to balance an equation by using algebraic equations. Thank you all for watching this class. You can download notes of today class by visiting the website pavitrachemistry.in, pavitrachemistry.com, pavitrachemistry.org. At last, I would like to give a like to make to motivate me for preparing next video. Share the video to reach your other student. Subscribe to this YouTube channel to support the class. Click the notification bell to stay updated with the latest class. Think like a proton. Stay positive with Pavitra Chemistry. Have a nice day.